Greetings everyone and welcome to today's webinar, Quality Assurance of Laboratory Test Results based on ISO 17025. Happy to have you all here with us. I am Arta Lamani, the Account Manager of Quality Management Systems here at PECB and the organizer of this webinar. This webinar will be presented by Hamidreza Dehnad, PECB Certified Trainer and CEO of PQP. Please feel free to write your questions and comments in the question box in the right-hand control panel, or you can use the raise hand function. We will unmute you and you will have a chance to ask the question directly. Hamidreza will answer to all questions accordingly at the end of the presentation. Please, Hamidreza, you may continue with the presentation. Thank you.
Okay, thank you very much. Hello everybody, this is Hamidreza and I'm going to present the topic of quality assurance for laboratory based on ISO IEC 17025 today. First, I would like to introduce myself very briefly, then we will proceed with the slides. As mentioned, my name is Hamidreza Dehnad. I have been involved in laboratory accreditation since 2003. As you can see in this slide with my contact information, I have worked in different industries. I started my job as a laboratory quality manager, and then I continued my professional career as a trainer and consultant in different industries and worked with different accreditation bodies for accrediting more than 75 laboratories in different industries. And I hope that my presentation would be interesting and you enjoy it. So we will start with the slides. As you know, one of the most important elements in ISO 17025 standard is quality assurance of results. ISO 17025 is a package, involves the quality management systems besides the technical. These two most important issues together will make a laboratory competent, and the quality of the results has three characteristics which should be considered. First, the fitness for purpose. It means that the results should be meaningful for the customer of the laboratory, for the laboratory receiver of the results, and which uses the results for making a decision to reject the product or accept the product. It might be food or drug or different things that might affect our health, and industrial, commercial values might be affected by this fitness for purpose characteristic. Besides this important characteristic, we have the validation. Here in ISO 17025, when we talk about validation, we mean methods should be technically clear and methods sound should produce technically valid results. In the validation of the results, we go through a method, even a standard method or in-house method or a method, modified method. We evaluate these methods. We check the performance characteristics of the method, such as accuracy, precision, measurement uncertainty, linearity, and other features to see if our method produces valid results. And the last part, which is our topic of the presentation, is quality control of the results, which means that laboratories should have a continual system to check and monitor to see if the results are valid. In validation, it's a one-time job, but quality control is a continuing job in the laboratory and should be done internally and externally. We will talk about this issue in upcoming slides. As you know, when as I mentioned in my in the first slide, the results of the laboratory should have a certain quality because they are the basis of decisions which might be legal, ecological, economical, and in the international market, when we talk about this, in a day millions of tests are made. in order to approve a product or approve a factory for the environmental issues or other things. So they should have a certain quality. When we talk about the quality of measurement data, some features might be in the data. Accuracy. You know that accuracy means the closeness of a test result with the true value. Sometimes the true value is not known. We sometimes have the agreed known value. It should have a known uncertainty. How much we are sure about our results. Should we consider an interval for our results? It means that for a laboratory, in an accredited laboratory, when we report the result, it is not technically, from the metrological point of view, it's not technically right to report only one number. We should inform our customers, the laboratory users of the results, with an interval that we believe that the true value will be in that interval. And the last characteristic is the compatibility of the results with other analytical measurements. It means that we should have repeatable measurements. We call it the precision of results. So when all these features are present, we can assure that our results are have the certain quality and are technically valid. Okay. Quality control, when we talk quality control in the laboratory, is a combination of the actions of the plans that the laboratory have in order to monitor the validity of its results. It's a very important sentence in ISO 17025. The laboratory should continually monitor the validity of the results. The actions that we use, for example, we might use some certified reference materials. We might use some internal quality control materials. We should compare the results of different analysts in the laboratory. All of these activities, when we combine them, we call them quality control plan or quality control activities in the laboratory. Okay. Sometimes our quality control is planned and done internally. It means that in a laboratory, we repeat the analysis, we compare the results with a reference value, but sometimes we compare our results with external sources. The most important mechanism we have in the world is proficiency testing. We call it PT programs. When you participate in proficiency testing, as you know, you compare your results with other laboratories. An independent organizer, sometimes it is an accredited one, organizes such a program in order to let you to compare your quality with other laboratories in your industry to see how valid are your results. Okay, in internal quality control, different activities can be done. Sparking. When we talk about sparking of samples, it is adding a specific amount of our analytes, of the parameter that we are going to measure, to our matrix, to our sample, and to see if we are able to measure the correct value, because we add a known amount of that analyte to our matrix. Sometimes we analyze blank samples. When we talk about blank samples, we mean in chemistry, we mean that samples which in that sample the analyte is not present. We want to check if there is any pollution in our reagents or equipment or measurement system totally. Sometimes we repeat our measurements in order to see if our results are close together. Sometimes these closeness are mentioned in our test methods. It means that our test method provides a criteria for us to see if our measurements repetitions are repeatable, and we can compare our repeatability with these criteria mentioned in the test methods. System suitability tests for some laboratory equipment, these tests are defined, and at the beginning of every run we use these tests. Usage of different analytical standards. Sometimes when we use an analytical reference standard or reference material to calibrate our device, it would be a very good idea for the laboratory to check its own measurement procedure with an independent reference standard to see if everything is okay with the measurement system. Sometimes we compare two different instruments together. In large laboratories, sometimes we have different equipment for the same purpose. So we should have a system in order to compare the outcome of all the instruments and to check that if they are not significantly different from each other. The same story for the analyst or for different methods which might exist in a laboratory. So the whole package of these activities can be done in a laboratory in specified time intervals to enable laboratory to be sure that they produce technically valid results, as I mentioned. When we call external quality assurance or external quality control, usually we talk about inter-laboratory comparisons. Sometimes these inter-laboratory comparisons only involve a very small group of laboratories. Sometimes large number of laboratories participate in such comparisons. The most powerful mean for quality control is proficiency testing. Proficiency testing is the performance evaluation of laboratories by means of inter-laboratory comparison, which means that an independent body sends some unknown samples to the laboratory and asks the laboratory to perform some tests or measure some parameters on those samples, and then they compare the results with a consensus value or with an assigned value, with a reference value, and each laboratory can see if its results have the certain quality that we have talked about. Sometimes these proficiency testings enable the laboratory to benchmarks. You know, benchmarking is one of the most important advantages of proficiency testing, because we can see which method has the best satisfactory range in a proficiency testing. In different industries, these proficiency testings are available, and if you search in the internet or Google proficiency testing with your test methods, you can see lots of proficiency testings available. There are some databases. It's because this mechanism, proficiency testing, is an independent mechanism for the laboratories to check the results. Sometimes it is a must from the assessors or auditors' point of view that they ask the laboratories to participate in such programs. In ISO standard, it is not a must. It is one of the quality control mechanisms recommended by the standard, but most of the accreditation assessors ask for your laboratory to participate in such programs. Okay, let's go briefly to ISO standard and see what requirements are written in class 5.9. The laboratory should have quality control procedures. Okay, there should be a written procedure or several procedures for quality control that maybe we write this procedure for each of our test methods separately, or maybe we have a general quality control procedure. In that procedure, we define what mechanisms in our laboratory exist for quality control of different test methods within the scope of accreditation of the laboratory. And then the standard asks that the laboratory should record such monitoring or quality control programs in a way that trends are detectable. It's very important that we should see the trends, how our accuracy or precision or trueness are changing through time. This sentence sometimes is interpreted as quality control charts. You know, some of you or most of you should know about quality control charts. Quality control chart is a graphical mean that enables us to monitor the changes in our test results in a period of time to see how are the changes. Are these changes limited in our acceptable range, or these changes are out of? A systematic error happened, a random error happened. We will go through these systematic and random errors to see what they mean. Okay, so a similar mechanism like control charts should exist in a laboratory in order to enable them to detect the trends of their data changes. And the statistics can be applied. So in order to implement this class in a laboratory, we should know about the statistics. Statistical techniques are very important for the laboratories. Different techniques are available and different material are available in internet or in other resources for you to go through them and see what techniques can be used in your laboratory for reviewing of your results or outcome of quality control. In this slide, it is from ISO text. Some actions or some mechanisms are recommended by the standards that, for example, regular use of certified reference materials or the so-called CRMs, or internal quality control materials. Some laboratories produces some reference materials or QCMs, quality control materials, internally in their laboratory, and they assign a reference value to them in order to enable them to check their test methods in different times. Participation in interlaboratory comparison or proficiency testing programs is also recommended by standard, as you can see. We talked about it. Replicate test, another important and the most, the easiest thing to do in a lab is this replications, because when you repeat a test, you can easily monitor the precision of your methods. How are the results close together? And we can monitor the precision, as I mentioned. And retesting or recalibration of retained items, as you can see in this slide, is another thing. When you have a stable test item in your laboratory, it would be a very good thing to test this item from time to time in order to see the stability of your results in the laboratory. And the last one is the correlation of results regarding different characteristics in the test item. Okay. ISO standard class 5.9 have some interactions with other standards. With class 4.9, class 4.9 is about the control of non-conforming work or control of testing non-conforming work. In quality control programs, when we run quality control activities in our laboratories, we may see some out-of-control incidents. It happens in the best laboratory in the world. So we should have a system in place, class 4.9, in order to manage this non-conforming event. Sometimes we need to stop our routine job in order to prevent the laboratory to report a wrong result to its customers. Okay, in class 4.13 we talk about control of records. As you noticed in the previous slides, we talked about the recording of the results for quality control programs. So class 4.13 are also connected and interacted with this class. Who is responsible? Class 4.9, control of non-conforming work. One of the inputs for corrective action process in every laboratory is the quality control, quality assurance activities. Sometimes we identify some problems in our routine jobs. So it's an input to the corrective actions in the laboratory. You should know that corrective action starts with CAT analysis, and then sometimes we can identify even preventive actions in quality control programs in our laboratory. Okay, what variables can affect the quality of the results in the laboratory? It's personnel. The qualification of the personnel is one of the most important features. Sometimes, maybe from a quality control plan in the laboratory, we can identify the training needs in our laboratory. So we can see what is missing in our personnel that showed in quality control activities that we have some problems or some non-conformities in the laboratory. Conditions of the specimens. Sometimes the laboratory doesn't have a good system in order to handle the specimens. Sometimes our test samples need to be stored in a specified storage rooms, or in some temperature requirements might exist. Okay, these variables might affect the quality of our results. The controls that you use in the test runs, different controls, control of temperature, pressure, it depends on the test that we should apply. Reagents in chemical industry we use. In chemical testing, we use lots of reagents during our test, and these reagents should have certain quality. Otherwise, it might affect the quality of our results. Laboratory equipment, from a calibration point of view, from maintenance, these are defined in another class in ISO 17025. Interpretation of the results, sometimes, or the transcription of the results, reporting of the results. These things might happen when we have a calculation error in a laboratory. We have a program, a software program, some error exists in such program, so it might affect the quality of our test results. Okay, let's go and talk about errors, because in quality control programs, when we run quality control in our laboratories, we want to identify errors. We want to see if our analysis or if our testing process is error-free. Error means the difference between a measured value and a reference value. But we have two different types of errors, systematic error and random error. Systematic error is an error which remains constant in replicates. It means that this error exists in your laboratory, and it is not a matter of replicating or increasing the number of the tests in your laboratories. Sometimes our equipment has some calibration correction or corrective correction factors which should be applied. When we don't apply them, systematic error happen. When our analyst, the operator who performs the test, has a constant mistake in its operation. So systematic errors can be easily detected and can be easily removed because they are constant in replicates. But random errors are the errors that changed unpredictably. It means that when you repeat the test and you see the difference between different test results, maybe you repeat the test in constant conditions, nothing has been changed, but the results are different. So random errors pattern is completely different from systematic errors. Random errors happen in every test methods. We should, and it is not easy to remove them because the source is unknown. Sometimes they are called unknown errors because the source is unknown. So the only mechanism exists for decreasing the effect of a random error is to repeat or increase the number of your replicates for testing. It means that you should have a system in place in order to increase the number of your replicates, so you can, with increasing the number of replicates, you can decrease the effect of random errors in laboratory. It's very important. All the quality control arrangements in a laboratory has a certain purpose, and the purpose is to control the systematic and random errors and to check if they are within our acceptable range. And this is a very famous slide you see in every book, every reference, the difference between accuracy and precision. You see 4 different states. In number A, you see the results, the outcome is not accurate. None of the points are in the target. And the points are not close to each other, so low accuracy, low precision. But in item B, we see that the points are close to each other. So we have a good precision, but the accuracy is not low because we see a systematic difference from the target. Case C, high accuracy, low precision, and case D is the perfect situation. Good accuracy and good precision in the laboratory. Okay. 2 other terms that I would like to discuss during my presentation is the repeatability and reproducibility. Repeatability is also called within run precision. It means that the closeness of the results in a fixed or in constant conditions. Nothing is changing. We repeat the test and we see how much are the results are varied from each other. If the results are very close to each other, we can say that our test method is repeatable. Reproducibility is between run precision. When the situation, equipment, different laboratories, sometimes different operators, different test methods, different reagents, and when we change the factors that can affect our test methods, and we would like to see if the results are still close together. This feature is called reproducibility. In your quality control program, you should monitor both features, repeatability and reproducibility. Both of them are important for laboratories. Okay, we talked about systematic and random error, and this slide you can see the exact definition of these terms. Systematic error affects the accuracy of the laboratory, but random error affects the precision of the laboratory. In random error, the true value is not important. We would like to see the spread of the results around the mean, but in systematic error, we want to see how our results are close to the true value. Okay, other term and other feature which should be controlled in quality control program is the bias. Bias is the same as systematic error, but it's a quantitative term. Bias means the difference between the average of your test results with the reference value. Sometimes your test methods, mostly in ISO or ASTMs, the bias, the acceptable bias for the test method is specified within the test method, and you should compare your laboratory bias with the so-called criteria mentioned in your test method. Okay, and we talked about precision. Precision has two different conditions: repeatable conditions and reproducible conditions. In both situations, we check the precision, but in repeatability, we check our precision when everything is constant. It's an ideal situation in laboratory. Nothing is changing. Okay, and reproducibility is the actual situation happening in your laboratory. When things are changing, time is changed, equipment, analysts, or different factors which might affect your laboratory is changing. So in precision, as I mentioned, both of these features should be monitored. So when you want to plan your quality control activities in your laboratory, you should keep in mind that precision in terms of repeatability and reproducibility should be checked, and also your systematic error or your bias should be checked. Different means are available. For example, proficiency testing is a tool for checking your bias or systematic error within your laboratory. Let's see here. Operator A has a certain bias. If we consider the red line as our true value, we can see operator A has a very low random error because the results are very close together. But the systematic error is considerable because there is a systematic difference between the average of operator A and the actual value, the red line. Operator B is the perfect one because the results are not very varied with each other, and the result is almost close to the true value. So low random error, low systematic error we can see. Operator C, the systematic error is very low. The bias is very low because the average, the violet point, the average point is very close to the actual value, but the results are not very close together. The precision is not good. The repeatability is not very good. So we see how we interpret the precision and accuracy or trueness in the laboratory. Okay, let's summarize the random and systematic errors. Random errors affects our precision. We can check it with reproducibility or repeatability, under reproducibility and or repeatability conditions, or intermediate precision. And systematic error affects the accuracy of the laboratory, and we would like to see how the results are close to the true value. Okay, it's another slide to see graphically what is the difference between the accuracy and precision. When the laboratory would like to plan for the quality control program within its laboratory, they should keep in mind the different approaches that they might consider. Sometimes our laboratory receives large batches of similar materials every day. These laboratories exist in production facilities. Similar materials, large batches. The quality control program in such laboratories should be a time-based program. The second one, large batches of samples with widely different matrices, different samples. Okay, these are the second-party laboratories. Sometimes it's a very difficult job for these laboratories to plan for their quality control because the samples are different in the nature, and it should be a mixture of time and sample type, the approach that we should consider for QC planning. And the last one is the wide variety of different tests in small batches. Usually we recommend these laboratories to have quality control before every test in order to assure about the quality of their results. Okay, this slide, we had it at the beginning, a similar one. Different mechanisms that can be run in a laboratory in order to check the results. I would like only to talk about the last one, phantom or ghost sample. In phantom or a ghost sample, laboratory manager knows the true value of a sample. It might be reference material. But he keeps it confidential with himself and gives the sample to the laboratory analyst to see if they can measure the true value. Sometimes these mechanisms can be defined in laboratory quality control program. The statistical techniques which can be applied, as I mentioned, control chart, the graphical tool, critical differences evaluation, the difference between two replicate test results. Significant tests such as t-test, f-test. If you're interested, you can search more for these terms and see how you can apply those techniques in your laboratory. Okay, thank you very much for your information. This topic is a very, we can talk hours with this topic, but if there is any question, I would be happy to help you. Thank you very much for your attention.
Thank you, Hamidreza, for this presentation. Now with the time left, we'll go ahead with questions. Therefore, if you have any questions, it's time to ask them. Please use the comment box or the raise hand function. Thank you. The first question here is, in your experience, can you give some examples of necessary preventive actions laboratories fail to consider?
Okay. The preventive actions that laboratory can consider, when the preventive action is, the source of the preventive action is the quality control, is changing the calibration interval of your equipment. You know, have a calibration interval closer to each other. Or changing the intermediate check of your, intermediate check is a user check. The user of the equipment can check. These examples can be the very good examples of preventive actions arise from quality control activities. When you see almost poor performance in your quality control laboratory, but it is not unacceptable at the moment, you can change this factor in order to have a very good preventive action within your laboratory.
Thank you. I have a hand raised by David Smart. I'm going to go ahead and unmute you, and you can go ahead and ask your question. Go ahead, David.
Thank you very much. My question is, if you can tell me quickly, what's the difference between the 2005 version and the 2012 version of 17025?
Sorry, could you please repeat your question?
What is the difference between the 17025, the 2005 version of it, and the 2012 version of it?
I couldn't hear you. The difference between 17025 and the other standard, I didn't.
No. Sorry, can you say it?
I believe the question is the difference between the 2005 version and the 2012 version. Is that right, David?
That's definitely correct. I've recently been asked this question and had difficulty finding it. And if even after this webinar, you could send me a correlation matrix, that would be very, very handy.
Okay. Thank you very much for your question. At the moment, the last version of ISO 17025 is 2005. But the standard is under revision by the CASPO committee. There are going to be revolutionary changes, but at the moment only we have the committee draft. The DIS should be published very soon, but at the moment the last version we have is 2005. You can check it in either website.
Thank you. I have another comment. They would like you to elaborate a little bit about uncertainty. It mentions that you didn't talk about that.
Okay. Uncertainty is the, how much you are sure about your test results. When you report your results, for example, like 10 plus minus 2, it means that you are not sure about the 10 that you measured in your laboratory. Okay. How we can measure this plus minus 2? This plus minus 2 is called measurement uncertainty. There are different approaches exist. For example, we have the so-called classical or bottom-up approach that we identify different sources that might affect our test results, and then we quantify the probable effect of every source, and then we combine them and calculate its plus minus. Uncertainty is a concept which means that the result of the laboratory should not be a specific number. It should be an interval, and we say that we are sure about this interval. The result, the actual value of the test within the, for example, is 10 plus minus 2 as I mentioned. But it's a very complicated issue, and we need several hours to talk about measurement uncertainty and how we can estimate that.
Thank you. I have another hand raised. However, it seems that this person does not have a mic. So if you could please write in the chat box your questions, and I will go ahead and read them out. Until then, the next question is going to be, in your experience, what should practically laboratories implementing ISO 17025 focus on when achieving quality test results?
Sorry, I had some technical difficulties. Could you please repeat the question?
Yes. The question is, in your experience, what should practically laboratories implementing ISO 7025 focus on when achieving quality test results?
Okay. The main focus should be on proficiency testing as the most powerful and independent tool, as I mentioned. You should participate in proficiency testings. The second one is having certified reference materials or reference material in your laboratory. These are very good things to let you check the accuracy and precision of the results. And the third thing is having control charts in place. Control chart is very easy to interpret, and everyone in the laboratory can use this and interpret how things are changing in our performance.
Thank you. The question that was raised earlier is, I did not quite get exactly your explanation regarding the known uncertainty. Is it some kind of hypothesis?
Known uncertainty, I meant that you have to estimated uncertainty, I meant. You know, because when in ISO 17025, it doesn't use the term calculation for uncertainty. It says estimating the uncertainty, which means that you should consider the most important factors which might affect your test results, and then quantify those factors, quantify the effects of those factors, and have an estimated uncertainty. Thank you very much for your point. We should use the term estimated measurement uncertainty.
Thank you. Another question is, what is, according to your experience, objective evidence to make calibration plan? Assessor here asks some calculation for that. What is the experience in other countries?
For planning the calibration, there are different approaches in place, but you know, standard only needs the laboratory to define the interval between the calibrations, for planning the calibrations. These, I myself don't like this quantification and some these models in order to, because you know, you should consider different factors when you want to define the calibration plan or define the interval between your calibrations. The history of that equipment. How important the test is for you. How often do you use your instruments in your laboratory? What are your required uncertainty? What is your customer expectation? What is the manufacturer recommendation? You should consider all of them and define the calibration interval based on your experience. I don't agree with this mathematical and statistical model that gives you a number. The best person and the best approach is the laboratory technical manager defines it based on the points that I mentioned.
Thank you. Another question is there a difference between duplicate and replicate analysis as elements of QC mechanisms?
Yes, duplicate means repeating a test in when everything is constant, nothing is changed. Even the time is very important. You repeat one after another. This is called duplicate. But in replicate, the situation is reproducible. Different operators perform the same test. Different times. I test the same item in different times, and then I compare the difference with the critical value. These are the difference between duplicate and replicate.
Thank you. Another question is, should the method used to calibrate be included on the calibration certificate?
Yes, according to ISO 17025, the calibration method should be stated on the calibration certificate.
Thank you. And the last question for today is the implementation of ISO 17025 a law requirement in many countries?
Pardon, could you please repeat the question?
Yes. Is the implementation of ISO 17025 a law requirement in many countries?
Sorry again, I have some technical difficulties with my internet. Could you please repeat the question one more time?
Sure. Is the implementation of this standard a law requirement in many countries? I'm sorry.
Yes, I don't know if I get the question correctly, but in different countries it can be applied. It is not, it's an international standard and it can be applied in every country. And in most of the countries in the world, this is the only criteria used for laboratory accreditation. Yes.
Thank you again for this great presentation. Because of the time limited, we will have to conclude this presentation. However, if you have any other questions, you can send your questions through email and we will answer to them individually. I want to thank all attendees as well for taking the time out of their busy schedules to join us today. We hope you enjoyed the webinar. To keep up with our webinars, please check PECB's webinar schedule on our website, pecb.com, or our official social media network. Since next week, we're organizing webinars on interesting topics. Thank you again, Hamidreza, for the great presentation.
Okay. Thank you very much for your time.
Our pleasure.
Mine too. Thank you very much.